Hey y'all, today we're going to be talking about factoring. Now, factoring is a brand new idea. It is something that we can do to help simplify our quadratic equations and define some of our things like our x-intercepts or our roots. But we're going to learn two different skills today. We're going to learn how to find a greatest common factor, which is kind of an early step to factoring. And then we're also going to learn how to actually factor using the CAB method and the box. So let's first look at what we call the GCF, or the greatest common factor. So common and factor just refers to something that all of the terms, remember a term is like a certain number of x's or a value that is separated by addition or subtraction in an expression or in an equation. So common factor means all of the terms have that piece of that factor in common. Okay, so let's look at A and kind of start talking about this. So we have x squared plus x. Hopefully right off the bat, you notice that both x squared and x have x in them. Okay, so that means they have a common factor of x. If I was to take x out, I have an x value to take out of each of these terms. Okay, now one is x squared. So I would say that my greatest common factor is probably x, because if the other one's x squared, I can't take x squared out of both. I can only take x out of both. So if I say that my GCF is x, then what I do is I take x out of both terms. So my simplified expression would be x parentheses x plus 1. Okay, now that's probably a little bit weird, okay, because essentially what I did is I undistributed x from my equation. So really what you need to think about when you're writing these, you're taking that GCF out, is that if I was to go back and re-multiply, x times x is x squared, x times positive 1 is positive x. Okay, so if I was to go back and re-multiply it, then I should get the same original equation. So that's what we're doing when we take our GCF. We're taking out a common factor that can come out of both terms, and if I was to multiply both of those terms by that factor again, I should get my original expression or equation. So let's look at our next one, B. So we have 4x minus 6. So they don't both have x's, so I don't think x is going to be a part of our GCF. They are both even numbers, 4 and 6. So if they're even, that means they're both divisible by 2. Okay, now they're both divisible by 2. Let's try to keep going because we want the greatest common factor. So if I could pull out a number larger than 2, that would be awesome. So are they both divisible by 3? No, 4 is not divisible by 3, but 6 is. So can't go to 3. 4 is divisible by 4, but 6 is not. And then I can't go any higher than 4 because 4 is the highest number that I have. So the greatest common factor that we found was 2. So our GCF is going to be 2. So then over here, if I took 2 out of both of those terms, then I'd write 2 on the outside of the parentheses. And I'd be left over with both of those. Think about it, if I divided both of those terms by 2, what would you have left? So 4x divided by 2 would be 2x. Negative 6 divided by 2 would be negative 3. Okay, part C, 2x squared plus 8. So once again, we do not have x's in both of these, so x is not going to be a part of it. But 2 and 8 are both divisible by 2, and since one of them is 2, I can't go any higher than 2. Okay, so my GCF once again would be 2, which would make our simplified expression 2 on the outside. 2x squared divided by 2 would just be x squared. 8 divided by 2 would be 4. And last but not least, D, we have 3x squared plus 1x. Okay, well, the lowest number we have there is 1, so I can't take out any higher number than 1. Okay, they do both have x, though. They do not both have x squared. So 1x, or just x, would be the greatest common factor that I could take out of both of these terms. And so if I take x outside, 3x squared divided by x would just be 3x, and x divided by x would, of course, be 1. And you can always check your work when taking out a GCF by saying, okay, if I multiplied that back out, would I get the original? Okay, so Finding a GCF is really the first step in our full factoring. Sometimes you can fully factor something by taking a GCF. Sometimes we have to do a little bit more. And so we call this the CAB method. Notice how all of our quadratic equations today are in standard form. And just as a reminder, standard form is that form ax squared plus bx plus c. And that's important because the CA and B in the CAB method refer to the CA and the B in your standard form equation. So the first thing we want to look at is we want to look to take out a GCF from the entire expression, if there is one. So number one, we have 1x squared plus 7x plus 6. So all these terms do not have an x in common, and 1, 7, and 6 are not divisible by a number larger than 1. Okay, so I don't have a GCF. I don't have anything that I can take out. So I go ahead and I go to step 2. So step 2, we want to multiply a times c. So 1 times 6, remember, so 1 the number in front and 6 the number at the end, and that's not a great 6. And that is equal to 6. Okay. Once we do that, we want to list all of the factors under the CA section. Okay. So 1 times 6 equals 6. That's our A times C. So now we want to find factors of 6. So factors of 6, remember a factor is two numbers that multiply together to get my number. Okay. So some factors of 6 would be 1 and 6 and 2 and 3. Okay. 1 times 6 is 6. 2 times 3 is 6. Those are the only factors of 6. Okay. Next step is I want to add the two numbers together. So 1 plus 6 is 7. 2 plus 3 is 5. Now 5 and 6 are kind of the same step. We're just going to go through and we're going to compare the b value we got to the b value of our equation. So our b value in our equation is 7. Over here, 1 plus 6 is equal to 7, so that one's good. 2 plus 3 is equal to 5, so that one is not good. Okay, so once we have the numbers that multiply to equal CA and add to equal B, you will put them in our box in the correct spots. Okay, so this is the key part. This is how we take our CAB method and we move it over to the box method. Okay, so over in our box, if you remember, our box method is how we use to multiply binomials, do our double distribution. So now we're using the box method to go the other way. We're actually splitting up our quadratic equation into two binomials, into two factors. Okay, so your A term goes in the top, your C term goes in the bottom. So our A term in this case is x squared. Our C term is 6. And then your C and your A make up the other two. So because 1x plus 6x should equal 7x. And now this gives us our factors. So notice how, just like we've done the box method before, x times x is x squared, x times 1 is 1x, x times 6 is 6x, and 1 times 6 is 6. So our factors for this one are x plus 6 and x plus 1. Okay, and that is the CAB method. It's a lot of kind of moving parts, but you're going to get better at them as we work through it. Okay, so let's look at another one, number 2. So we have x squared plus 7x plus 12. And y'all feel free to pause me and ask a question in class if you are confused about any of these steps. So once again, we have ax squared plus bx plus c. So a is 1, c is 12. So 1 times 12 is equal to 12. So then I want to write factors of 12. So we have 1 and 12. We have 2 and 6. And we have 3 and 4. Okay. Then I want to add those together to see if they match up with B. So 1 plus 12 is 13. 2 plus 6 is 8. 3 plus 4 is 7. So 13 does not match 7x. 8 does not match 7. 7 matches 7, though. So 3 and 4 are going to be our factors. So x and positive 3, x and positive 4. X times x is x squared. 4 times 3 is 12. X times 3 is 3x. And x times 4 is 4x. And just so we can check, x squared is x squared. 12 is 12. 3x plus 4x would give us 7x. So our final factored form is x plus 3 and x plus 4. So far, so good. Okay. Number 3, we have x squared minus 5x plus 6. Okay, so this one's a little bit different. All of a sudden, we have a negative in the middle. So we'll talk about how that might affect some things. But let's start out with the first part first. Okay, we don't have any GCF, so we're going to go ahead and multiply a and c. So 1 times 6 is equal to 6. Then I want factors of 6, which we've done this before. 1 and 6 and 2 and 3. But here's the issue. We want to add up to negative 5x. Okay, so not only do we need to think about positive factors, we also need to think about negative factors. Okay, so if both of my factors were negative, so if instead of it being positive 1 and positive 6, it was negative 1 and negative 6, that would still equal positive 6. But now, if both of the factors are negative, they can add up to a negative b value instead. So because my b value is negative, instead of listing the positive 1, 6, and 2, 3, we want to list the negative version of all of those. And then we are still going to add and check if they add up to b. So negative 1 plus negative 6 is negative 7. Negative 2 plus negative 3 is negative 5. Negative 7 does not match negative 5. Negative 5 does match negative 5. So now when I come over to fill out my box, I have x and x, negative 2 as a factor, and negative 3 as a factor. So x times x is x squared. X times negative 2 is negative 2x. X times negative 3 is negative 3x. And negative 3 times negative 2 is positive 6. And just to check, does negative 2x plus negative 3x equal negative 5x? It does. So we are all good to go. So our factors in this case are x minus 2 and x minus 3. All right, let's look at one more today. We have 2x squared plus 10x plus 8. Okay, so remember, first step is we always want to check for a GCF. And this time we have 2, 10, and 8. You might notice that we do have a GCF. Okay, all of these numbers are even, which means they're all divisible by 2. And so 2 could be my GCF. I also noticed that 2 is already the lowest number, so I can't pull out a number any higher than 2. So that means not only is 2 possibly my GCF, 2 is my GCF. So if I take a 2 out of all of these terms, so I'm dividing every term by 2, so 2x squared divided by 2 would be 1x squared. 10x divided by 2 would be 5x. And 8 divided by 2 would be 4. Okay, so this is my new standard form function that I'm working with. I'm going to kind of ignore 2. I'm going to keep it with me all the way to the answer, but I'm going to ignore 2 for the sake of our CAB method factoring. So once again, I take the A value and the C value, so 1 and 4, so 1 times 4 is equal to 4, and I multiplied both of them positive because we're all positive all the way across. So then I want factors of 4, so 1 and 4, and 2 and 2 are my factors that multiply to 4. Then I want to add those factors together to check for B. So 1 plus 4 is 5, 2 plus 2 is 4. 5 matches 5, 4 does not match 5. So we know that our factors are 1 and 4. So x and positive 1, x and positive 4, x times x is x squared, x times 1 is 1x, x times 4 is 4x, and 4 times 1 is 4. So just to check, x squared, 4, and then 1x plus 4x does equal 5x. So then in my final answer, I'm still going to write my factors as x plus 1 and x plus 4, but I do still have that GCF of 2 out front. So I just leave that 2 all the way there in the front. And that is my answer. All right, so this is factoring when A is equal to 1, which just, it's a more simpler version of factoring. We're going to kind of explore factoring more and more here over the next couple of days. But go ahead and complete the practice after you finish these notes.